if what two things have to match? Do you remember? The left and the rights have to match each other. Okay, so I'm gonna put here if the limit as x approaches a from the left has to equal the limit as x approaches a from the right. Okay. So let's say for this first one, we're looking at the picture. Okay, we're gonna check the left limit, check the right limit. If they match, the limit exists. So remember, for the left side, you would draw your line in at 2. You would cover up the side you're not looking at and just see where the graph leaves off at. So as I trace closer and closer to 2, what's the left limit? Okay, what's the left limit? 4. And then I switch, I cover the other half. So that'd be this side. And as I trace in closer and closer to 2, what's my y value? 1, then do they match? No. So you would put here, the limit DNE does not exist because the limit as x approaches 2 from the left is 4, but the limit as x approaches 2 from the right is 1. Okay, remember, as far as the AP test goes, you can't just say they're not the same. You have to say what each side does equal. Okay. All right, now take a look at number 2. It's the limits one. Oh. Okay, take a look at number 2. Go ahead and just give it a shot. Remember, you're checking the left and the right sides to see if they match. So here's my x approach 1. As I look on the left-hand side, what's it approaching? 2. What about the right-hand side? Then if they're both 2, then it does equal 2. Okay, now the closed dot, remember, that's f of 1. So you would say that f of 1 is 1. Okay, but that has nothing to do with the limit. The limit, you're looking at what you're tracing towards. Okay. All right, let's go down to the next one. Let's look at number 3. So it says we want the limit as x approaches 1 on sine f of x. You should remember that the limit is just going to jump into the middle function. So I'm going to find the limit as x approaches 1 on f of x. Then when I find that answer, I'll take the sine of it. So looking at graph F, that's the first one. As I approach 1 from both directions, what is my y value approaching? 2. Then I would take 2, plug it into sine, and I would get the sine of 2. Okay, let's go right below that. Take a look at number 5. X approach 1 on g of f of x. Remember, the limit should apply to which function first, the outside or the inside? Inside, very good. So I'm going to take my limit as x approaches 1. I'm going to do that on f graph first. And then once I get this limit, then I'll look at the graph for g. So x approach 1 on f, what did we get for that when we did it just a minute ago? It was a 2. Then I'm going to try to find g of 2 on my graph. Okay, and if you look at g of 2, remember that would be my actual y value. G of 2 is. Okay, which ignore, I copy pasted the answer choices. Okay, so 1 is correct on that one. All right, let's do the next one, number 7. Okay, limit's gonna jump to the middle first, but since they're both f's, it really doesn't matter. So you would have the limit as x approaches 1 on f. Then you're gonna take that answer and plug it into f again. So look at your graph of f as x approaches 1. Okay, what's that value gonna be? 2. Then I go to f of 2. Now, there's a rule. I know it's been a long time, that this must be connected for you to evaluate. So when I go to f of 2, the graph has to be continuous at that point in order for me to pick that y value as the final answer. So when I go to f of 2, what is the actual y value where the closed dot is? 1, but I can't pick it because what? It's not connected, so you would have to pick D. Okay. Good on that? Go ahead and turn the page. Obviously, we're not going to have time to do every example. We're just trying to hit different topics. So if you have a graph, you check the limit from the left and the right, make sure that they match. Okay, on the next page, you're going to have limits where you have equations instead of graphs. So remember, if you get a factor in the denominator that cancels, that creates a hole in the graph. And those limits do exist. Okay, they're fixable. That if the 0 on the bottom can cross out, your limit still exists and it is fixable. Okay, however, if the 0 in the bottom does not cancel out, you have a vertical asymptote and your limit's going to DNE. So let me show you what I mean by that. Let's take a look at number 1. Okay, go ahead and plug in x is approaching what number? 3, right? So I'll just do 3 squared plus 7 over 3 plus 1. 3 squared is 9. 9 plus 7 is 16. 3 plus 1 is a 4 on bottom. 16 divided by 4 is 4. So this limit existed. Nothing weird. You could just directly plug it in. Okay, when I go to the next question, what's going to happen when I plug in my 2 on top and on bottom? Okay, so I'm going to have 2 squared minus 4 and 2 minus 2. But 2 squared is 4, which means the top is really 4 minus 4, which gives me 0. And then on bottom, I also get 0. So remember, when it's 0 over 0, remember you're gonna do more. Okay, and remember what do more means is 9 times out of 10, you're gonna factor cancel. So for the top, how can I factor x squared minus 4? X plus 2x minus 2. Then on the bottom, I see that I already have an x minus 2. And then I see those x minus 2s are going to cross each other out. So these guys are gone. And then remember, I'm going to retry that limit once I've factor canceled. So then I'd plug in 2 into the x spot. Now it's a 2 plus 2, which is. Okay, so that limit does exist because since the factors canceled out, my graph has a hole in it where that point is messed up, but the sides are both approaching. Okay, same thing for number 3. We're going to plug in our 2. So I have 2 squared minus 9 and 2 minus 2. On top, what am I going to get? 4 minus 9 is negative 5. And then on bottom, 2 minus 2 is 0. Okay, if they don't both come out to 0, factor cancel is not going to fix it. What is our conclusion with this one? DNE. Okay, and then if you remember on our little cheat sheet when we did this, we said it's okay to get 0 on the top, but no, you can't have 0 on the bottom. And then remember the third option would be that it could be 0 over 0. That's when you would do. Okay. All right. Next thing is L'Hopital's rule. So if factor cancel won't, we're doing an AP review session. You just put it on my desk. Okay. L'Hopital's rule is another way to fix limits. So if factor canceled won't work, L'Hopital's rule says that if you get 0 over 0, you're going to retry the limit. The limit as x approaches a of f prime of x over g prime of x. So if you get 0 over 0 on a fraction and factor cancel won't work, then you're going to retry the limit by taking the derivative of the top and the bottom. So if f over g gives you 0 over 0, try f prime over g prime. So let's say we're taking a look at number 4. I have ln x minus 1 over x minus e. What is my x approaching? That's a e. So then I'm going to plug my e in here, that I have ln of e minus 1 over e minus e on bottom. ln and e cross each other out. Do you remember you just keep a 1 in that spot? Which means the top is 1 minus 1, which is 0, over e minus e, which is 2. And remember, that's my strategy that tells me that I need to do more. Now, if factor cancel would work, I would try that. Okay, but obviously there's no way that I can factor that. So L'Hopital's rule is another way that I can get around the do more situation. What is the derivative of ln x minus 1? 1 over x. Very good. Now, what happens to the minus 1? If you're taking the derivative. Yeah, it just goes to 0. Okay, on the bottom, I have an x minus e. What's the derivative of x? That's the antiderivative. Take the derivative, would drop it down to a 1. And then remember, e is a constant. So if I take the derivative of e by itself, it also goes to 0, just like the minus 1 went to 0. And then once I take the derivative of the top and the bottom, I just try the limit again. So now I'm plugging in the limit as x approaches e. On top, I'm going to get a 1 over e. And then technically it is divided by 1, but we know that the 1 won't change anything. So what answer do we want there? A. All right, let's try one more of those. Take a look at number 5. First thing I want you to do is plug in that 0. So I'd have 7 times 0 minus the sine of 0. 7 times 0 is 0. Sine of 0 is 0. Subtract them, you're going to still get a 0 on top. On bottom, I'd have a 0 squared plus sine 3 times 0. 3 times 0 is 0. And remember, sine of 0, that's your pinky. You don't have any fingers below it, right? So this is going to go to 0 as well. And then since factor cancel doesn't really make sense on this type of question, L'Hopital's rule would be your other option. So take a second, take the derivative of the top and the bottom, and then try the limit again. Okay. So 7x, the derivative goes to what? 7. And then if it's a negative sign, remember snow cone, you're going down. What would you get? Negative cosine x. Okay, then on the bottom, my x squared, what's the derivative of that? 2x. And then if I have a sine 3x and I take the derivative, sine goes to what? Cosine 3x, and then do you remember chain rule times what? 3. Okay, remember that if it's not just a cosine x, you have to remember to times the derivative of that chord to the front. So we'd go to cosine 3x and then times an extra 3. Then remember, our goal is to plug in that 0. So I have 7 minus the cosine of 0. Does anybody remember cosine 0? It's 1. What's 7 minus 1 on top? 6. Okay, then on bottom, 2 times 0, this guy's going to cross out. Okay, but then what's the cosine of 0? 1, but I have to times it by 3, means that's really a 3. And then 6 divided by 3 is going to be 2. Okay? All right, go ahead and turn the page. Y'all are doing a great job. Okay, if you have limits to infinity, okay, remember that's where you're going to use your Bobo-Botten Betsy. Okay, I don't call it EPF anymore, but Betsy is where if they're the same, remember you try it. So take a look at number 7. Your n is going to infinity. That tells me I'm doing Bobo-Botten Betsy. What's the highest power on top? It'd be 4n squared. What's the highest power on bottom? N squared. Is it a Bobo bigger on bottom, Botten bigger on top, or Betsy? They're both equal. Betsy. And remember, both equal means divide the coefficients. So in this case, what would I be dividing? 4 divided by 1, which would give me. Okay. Now on number 8, you'll notice you have kind of the same story. Your x is going to infinity, but it's in factored form. Then all that you need to do is times out what the biggest thing would be on top versus the biggest thing on bottom. So I'm not going to FOIL out this whole thing. I really just care about what the x's are going to be when I times. So what is 2x times negative x? What kind of 2x squared? Negative 2x squared. You can put plus ... Okay, but we don't care about everything on top. We just care about the biggest thing. Okay, and then on bottom, what's x times x? Then is it a Bobo, a Botten, or a Betsy? Betsy, we're dividing those front numbers. That'd be a negative 2 divided by 1, which would be negative 2. Okay, for the next one, okay, if we have a horizontal line, y equals 2, and it says that it's an asymptote, I want you to draw what that looks like. So y equals 2 would be like this. And then they're not telling me what type of asymptote it is, but if it's a horizontal line, what type of asymptote does it have to be? Horizontal. So that means that on one of the ends of the graph, or maybe both, okay, my graph can do whatever it wants in the middle, but then it has to head towards that line y equals 2. It could be on this end, or it could be on this end. Okay, we don't know what happens in the middle of the graph, but horizontal asymptotes tell us what happened on the ends of the graph. So look at your limit statements here, particularly at D and E. Okay, and tell me which one of those says that the end of the graph approaches 2. E is correct. Now, when you look at x approach infinity, which end is that one talking about? The left end or the right end? The right end. The only reason you know it's the right end is what did they say for our x here? If it has to be greater than 0, then you have to be talking about this side. Because everything on this end, your x's would be negative. Okay? All right, a little bit more review here. Okay, continuity means the graph is connected. Okay, or some teachers will say you can draw it without picking up your pencil. Okay, versus differentiable means it has to also be smooth. Okay, so you can read right here what the features are. If it's not differentiable, it has a cusp or a corner. It could have a vertical asymptote, or it might not be connected. So looking at the graph here, it says at which value of x is our f continuous, but not differentiable. So it has to be connected, but it cannot be smooth. Okay, B, is it connected? The limit exists, but it's not connected because see my dots up here. It has to be A. Because do you see how I could draw that without picking up my pencil? But it is not differentiable because it has a what? Cusp. Now, one thing I do want to point out, okay, that's a cusp, is that at B, does the limit exist? Yes or no? Yes, but is it continuous? No. So remember, the limit exists just means you're headed towards the same point, but in order for it to count as connected, this dot would have to fill in that point. Okay, otherwise you couldn't draw it without picking up your pencil. Okay, go ahead and turn the page. All right, let's do this one right here. Okay, so they give you a piecewise function and they're asking you to show that it's continuous. Now, you have a study sheet that says this, okay, from long ago, but let's review what the parts are. The first thing that you have to check is your limit from the left and right have to come out the same. So I'm going to do the limit as x approaches 0 is my breakpoint. I'm going to check it from the left first. Then I'm going to check it from the right second. Okay, and these have to match. Now, if you remember, approaching 0 from the left means you're going to use the x less than 0 piece. So bless you, I would plug in my 0 right here, and I would have 1 minus 2 sine 0. Write that down. 1 minus 2 sine 0. But then what's the sign of 0? 0, which means really it's just 1. So my left side limit is 1. Now let's try our right side limit. If I want 0 from the right, I need numbers that are greater than 0. So I'm plugging into this bottom piece. I have an e to the negative 4x. That means I have an e to the negative 4 times 0, which would just be e to the 0, which is 1. So my left and my right pieces do match. Then I go on to part 2. Part 2 is that I have to have a y value. Now, your y value could be in its own little section. So it could say like, if x is 0, pick this y value. Okay, but in this case, we don't have that. Where is the equal to on 0? Top or bottom? Top, and it already came out to what? So we're not going to redo the math. Okay, but it'd be 1 minus 2 sine 0, which is 1. So my left and rights are 1. My y value is 1. The last step, part 3, is that these pieces have to match, which they do. So for part 3, you would just state that your f of 0 and your limit came out the same. Therefore, it is continuous. Now, for this question, you're asked, not only is it continuous for part A, but part B asks us if it's differentiable. So the only extra step for it to be differentiable is you're going to take the derivatives of the top and the bottom pieces and see if those match. So right next to your original f, let's find f prime. Okay, so for differentiable, we're going to take the derivative and find f prime. My top equation was 1 minus 2 sine x. What's the derivative of 1? 0. And then negative sign will go to negative 2 cosine x. E to the negative 4x, what would the derivative be? E to the negative 4x. Remember, e stays the same. But then because it's not just the x here, do you remember you'll times the derivative of that to the front? So if it's a negative 4x, what's the derivative of that? Negative 4. And then you would just plug both of those in to see if they still match. So let's do it real quick and then it'll be time to stop. So write down your limit as x approaches 0 from the left of f prime. And then your limit as x approaches 0 from the right of f. Plugging in a 0 on top, I'd have negative 2 cosine 0. What did we say the cosine of 0 is though? Cosine's 1, so 1 times negative 2 is a negative 2. For the bottom chunk, I'd plug in my 0. I'd have negative 4 times e to the 0. E to the 0 is also 1, but if I multiply it with a minus 4, do my pieces match? So I would say it is not differential. Okay. Questions on that? All right, it's 11:04. Get out your thing for me to sign. Okay, make sure that you write the name of the packet under the title part. And then I think the next page is some little practice questions. You can do them if you want, but it's up to you. Okay, and your session was called Limits, Continuity, and Differentiability. You need one? All have a great day. Here's the one. All have a great day. See you tomorrow. Thank you. Good job. Yeah, you'll take yours. Yeah, I have them. Bye, have a good day. This is, and then that's actually, these are the ones with this. And I'm gonna put them under, it'll be, you know, you have the quarter 1, 2, 3, 4. You'll have a fifth. Bye. Have a great day. I do have a lunch. Sure, I didn't finish. I finished all of one of the forms. Okay. But I didn't finish the other one.